Hi learners, welcome to the course. Our today's topic is schemas of a multidimensional data model. Myself Priyanka Gupta, I am working as an assistant professor in Department of Computer Science and Engineering, Data Science at Institute of Aeronautical Engineering, Hyderabad. So the topics I'll cover today, that will be the brief description of a multidimensional data model. In that concept hierarchy, I will cover schema of a multidimensional data. In that, star schema, snowflake schema, and the fact constellation schema. And then I'll discuss about what are the schema definitions and what are the different definitions for these three of the schemas of multidimensional data, which is star, snowflake, and concept constellation. Then we'll see what is measure in that tables. So let's start. So we have covered the multidimensional data model as an introduction. So our multidimensional data model is nothing but that is a most of the popular data model for the data warehousing, right? So while in the data warehouse, the data will be stored, so that will be in the form of the multidimensional, not in the form of the, like most of the data nowadays, it is in the form of the 3D data. So that is nothing but the multidimensional model. The multidimensional data model is composed of, that is having the data cubes, right? So the data is the 2D data, 3D data, and whatever dimension it will have, it will store in the form of data cube. So that will be the logical view of the data. Okay. Then there will be the one measure, right? So there will be dimension. There will be see the term hierarchy. Then we will see the term label and attribute. Right? So these are the introducing functions we can say in the data multidimensional data model. Right? So this model can exist into the form of star schema as well as in the form of a snowflake or fact constellation schema. Right? So that is a logical model of the same diagram. So here we can see the data cube is here, right? So the data will be stored in the form of multi-dimension, right? So that is nothing but in the form of data cube. So there will have the sum of the measures to identify the data by the measure. There will have dimensions of the data like row, column, and x-axis, y-axis, and z-axis. So there will be have some of the columns and rows. In dimension there will have a dimension attribute, labels of the dimension, and hierarchy of the dimension. So that is the logical level of the this multidimensional data model. Concept hierarchy. So as we have covered some of the topics, in that we have came to know about concept hierarchy. So exactly what is concept hierarchy? The concept hierarchy is a sequence of mapping from a set of low level concept to high level, right? So how? Like, because it is all the data will be shown in the form of map, right? So there will be hierarchy, there will be a mapping, right? So to show that type of mapping from the lower level to a higher level, so that will be present in the form of concept hierarchy, right? So more general for more general concepts. So concept hierarchy that allow data to handle by the very different levels of the abstraction. So what is abstraction? Abstraction is nothing but the hiding of the data. That is another we can say perception of the data. The data is stored, but we cannot see directly. So that data is comes into the logical abstraction of the data. So so all the data will have in the form of some labels, so that we can see in the form of some of the maps. So that in this figure we can see the concept hierarchy for the location. So for the location, for the all of the locations, it will start from the all of the location, then it will be divided into the country. So there will have some of the country. So in this data location, there is Canada and USA, and then it will divided the country although will be divided into their sub category. So there will be that will be divided into the form of province or state. So so in Canada there will be British Columbia and Ontario, right? So at the lower level, that will be divided into the cities, different city. So in the state or province, the city came. So the city will be Vancouver and Victoria and so on. And for Ontario, the cities will be like Toronto and Ottawa. So from the lower level, from the city and from the province, from the country, and from the all of the location, the data, this data has been described by the mapping. So that is nothing but the concept hierarchy for the location table, right? Location. So we have understand the what is concept hierarchy. That is nothing but the abstraction levels mapping onto the up to our use. So if we consider a concept hierarchy for the dimension location, as we have seen, so for the city values for location include the Vancouver, Toronto, New York and Chicago cities, right? So each of the city, however, can be mapped to the state or province, right? So from the lower level it will start and that will go up to the upper level, higher level, right? So it will be mapped with the which of the city, which of the state belongs to it. So from the lower level it will start and that it will go to the respective province or respective state. So for example, for the same example, if we are taking the Vancouver city, so that can be mapped for the British Columbia state, right? And if we are taking the Chicago city, it will be mapped with the Illinois, right? Illinois state or province, right? So these are the provinces and state can be in turn that can be mapped to the country, right? So although after that here the city was mapped with the province or state, then although again the province and state will be mapped to the country, respective country. So for example, if Canada US is there, so that for which they belong, for which specific province and state they belong, they'll go to the Canada as well as to the US, right? So like that the mapping is going from the lower level to higher level. These are the mappings from a concept hierarchy for the dimension location, right? So here we are in this example we have taken the dimension of location. So if we will consider a concept hierarchy for the location dimension, if we are taking the location dimension as we have seen in the logical level of the logical map of the same location. So for that the city values for the location that were Vancouver, Toronto, New York and Chicago. So these are the lower level mapping. So it will start from the lower level. So that is nothing but the city. So for each of the city that will map to the next level. So that is nothing but there are states and if you can say provinces for some of the country. So like that for that it belongs, for that it will be matched. So the city and after that province and after that country. So like that the whole of the hierarchy will be followed. So for example, if there is city Vancouver, that will be mapped to the British Columbia province, right? So and if there is a city Chicago, so that will be mapped to the province state Illinois, right? So these are the states and these provinces like British Columbia and Chicago that can be into the turn to the that will go to the country. So for the other mapping, it will be mapped to the respective country from which it belongs. Like if it belongs to the Canada, it will go to the Canada. If it belongs to the United States, that it will go to the United States. So like this, in the concept hierarchy, all of the hierarchy is following by the mapping. So these are the mappings from a hierarchy, concept hierarchy for the dimension location. There is a mapping that is mapping a set of lower level concepts, that is city, and to the higher level, that is nothing but the country, right? So the concept hierarchy, that is a total of partial order among attributes in the database schema, right? So concept hierarchy is nothing but that is a total order among the whole of the database for the attributes and in the for the whole of the database schema. So what we call it as in the database the schema hierarchy. So for the schema, we will call that concept hierarchy as a schema hierarchy. So the term is very useful while we are doing the mapping for the different levels, different dimensions. So that was all about the simple terminology of the concept hierarchy. There can be chance there can have the more than one concept hierarchy, right? So for the given attribute, we can say dimension. So based on that, that will be mapped on the different user viewpoint. So because the different user is having the different viewpoints, so they can have the possibility, they can they can construct a concept hierarchy more than one. So for example, if a user that is preferring to organize a price, right? So if there is a user that is organizing a price by defining the ranges for inexpensive, moderately priced, and expensive. So for each of the three ranges, there will have the three concept hierarchy, right? So it is up to the user also, because that is basically based on his viewpoint. So there can have the possibility of the more than one concept hierarchy, right? So the concept hierarchy may also be defined by the grouping values for a given dimension, or we can say attribute. So in the previous example, the dimension were location, we can say attribute. So that will be result into the subgrouping of the hierarchy also. So why we are saying the set grouping hierarchy? Because there will be the possibility, there will be some of the dimension may can have the more of the other attributes and dimensions, right? So for that, while we are doing the mapping, there will have the possibility of set grouping of hierarchy, right? So a total order can be defined among the group of value, right? So in this example, we can see in this figure, this is the concept hierarchy for price dimension, right? Price attribute. So in this example, the set grouping hierarchy for the dimension price. So where the interval $x to $y, right, denotes the range from the $x, that is exclusive, and to the $y, that is inclusive. So we can see in the example, the higher level attribute is $0 to $1000. So and again it will be subdivided into the what, that is set group subgroup of that dimension. So there are 1 2 3 4 5 subdimensions, and again it will be then it will be constructed like this. So this is the lower level, and that will go to the upper level. So that is a set grouping hierarchy of the concept hierarchy. So for the multidimensional data, there were the 2-3 type of schemas are there, right? So schema is nothing but the abstraction of data. So the first is star schema. So there will be the possibility the data will be in the form of like star, that the mapping will be formed like a star. So that that is called as a star schema, right? Star schema. So the star schema is a modeling paradigm in which the data warehouse having a large central table that is calling as a fact table. So we have seen the definition of that star schema, but today we will go into the depth of that. So the fact table is nothing but that is a larger central table for the dimension. What is the dimension here? For the sales, right? So it is having the sales fact table that is having the different attributes, that is nothing but the time key, item key, branch key, location key, right? And also having the attributes dollar sold and unit sold, right? So that is apart from that is having a set of smaller attendant table, or we can say dimension table. So the another name of the dimension table is that is nothing but the what is attendant table, right? Attendant table. So that will be associated with the central fact table, right? So for the each of the dimensions, right? So here we can see there are these are the attribute. We can also say that this is the dimensions, right? So for the time key, there is a time dimension attendant table, dimension table. So for that that is having the attribute year, quarter, month, day of week, day and time key. So for example here for the branch key attribute of dimension, that is having the branch dimension table, right? So that is also having the attribute, right? So for the item, there is a dimension table is item dimension. For the location, that is having the location dimension table, right? So like this, the star schema, it is looking like the star, right? It is forming the structure in the form of star. So we call as a star schema. So the schema graph that looks like a star burst. So with the dimension table displayed in the radial pattern around the central fact table, so which we have seen in the previous figure. So in that, each dimension in the star schema is represented with only one dimension table, right? So for the each of the dimension in the star schema fact table, there were a respective one dimension table, right? So this dimension table that is containing the set of attributes. So that were nothing but a set of attributes which is belonging to that. So in the diagram, sales data of company with respect to 4 dimensions were there: time, item, branch and location, right? So there is a fact table at the center. It contains the key of each of the 4 dimensions. So the dimensions are nothing but we can say as that are the key to the dimension table, right? The fact table also contains the attributes, right? So there were the attributes, those are dollar sold and unit sold, right? So the in the previous example we can see this is the data warehouse of the sales dimension, right? So that is a schema, that is a star schema for the in that fact table is sales, right? That is having the 4 dimension tables: time, branch, item and location. And in the fact table, what are these? I had told them that were the dimension, but in that we call as a for the fact table, that will be donated as the key. That will be donated by the key, right? And what are attributes and dimensions? So those are the attributes: dollar sold and item unit sold, right? So this is the difference in the fact table and dimension table. In the dimension table, these are the attributes. So in the fact table, these are the attributes, these are the key, right? So that was the difference between the fact table and dimension table. Next is Snowflake schema. So for in the each dimension, that is having the only one dimension table, and each of the table holds a set of attributes, right? So for example, if we take the example, the location dimension table, right? So that is containing the location key, state key, city key, and province or state country key, right? So this constraint may cause the data redundancy. How? We can see in the example. We are having the example in that Vancouver and Victoria both are the cities that is located in the Canadian province of British Columbia, right? So the entry, when we will do the entry for the such of the cities, that is making the cause for data redundancy, because there is having the attribute province and state, and that is having the country. So when that will map to the country and state, so there will have the confusion, there will have the data redundancy, right? So that is the so that we are using the Snowflake schema. So in the Snowflake schema, that is a variant of the star schema, right? But here we have the if we are having the sum of the dimension table that are normalized, and then it will be splitted again into the additional tables. So that is the difference. Like in the star schema, the dimensions table were associated with the fact table, but in the Snowflake schema, the dimension table will be again splitted into the additional tables. So that looks like a snowflake. So so the name came like Snowflake schema. So the resulting schema graph form a similar shape like a snowflake, right? So the major difference between the snowflake and star schema model is that the dimension table is of the snowflake model may be kept in the normalized form, right? So in the snowflake model, that the data will be normalized, right? So that is a difference. The star schema model, that the data is not normalized, and in the snowflake schema, the data will be normalized. Some of the dimension table in snowflake schema will be normalized, as I have said. So the normalization, splitting, what is the normalization? Because the normalization again, that is splitting into the additional dimension tables. So that is a difference, right? So unlike star schema, the dimension table in a snowflake schema are normalized. For example, for the item dimension table in the star schema were normalized, and then again it will be splitting. If that is normalized, then it will again is splitting into the two dimension data. So first will be the item and second will be the supplier. So that will be the two of the dimension. The first dimension table will be normalized and will be splitted into these. So this is the example of snowflake schema of sales dimension. So here we can see this is the sales. See, for the sales, that is the same example as we have taken for star schema. So for that we can check the item dimension table again splitting into the supplier dimension, right? So that is having the attribute supplier type, and the key is supplier key. The location dimension that was that is again splitting into the city dimension, and these are the attribute this table is having. So that is nothing but the dimension table. So that is the difference between the star schema and snowflake schema. So that looks like a snowflake, so the name came as snowflake. Fact constellation schema. No, rather than that, we are having some of the other things for Snowflake schema. So for the item dimension table, that is containing the attribute item key, item name, item type, brand, and supplier key, right? So the in the supplier key dimension table, that will be linked to the supplier dimension table. The supplier dimension table, that is containing the attribute supplier key and supplier type, right? So we have seen in the example. So due to the normalization into the Snowflake schema, there will be chance the redundancy will be removed. That will be removed, and then it will become a very easy to maintain, and that will save the storage space also. So after so the fact is the star schema came earlier, and then the some of the we can say cons were there. So after that the Snowflake schema came, so that will reduce the storage, while there will be chance of the redundancy that will not occur, right? So the first constellation schema, that is the some of the times the sophisticated applications may require some of the fact tables, multiple fact tables to while it is sharing the dimension tables. Though, so there will have the chances, there will have the more than one fact table and the respective dimension tables for that. So this kind of a schema can be viewed as a in the form of collection of stars, and we can say it as a galaxy. So the fact constellation schema is nothing but the we can say a group of the star schema, right? So that will looks like a constellation. That will be looks like a constellation. So that we are saying that is a galaxy and a fact constellation schema, right? See, so this is the example that is a fact constellation schema for the data warehouse of sales and shipping dimensions, right? So here the fact table is sales, and the another fact table is shipping, right? So there these are the more than one fact table here, right? And the respective dimension table that can be associated both of the fact tables, right? So for the sales fact, there is a dimension table time associated, branch, item, and location, right? Again, for the shipping fact table, there is the item dimension table, location dimension table, and shipper dimension table that is associated. So this type of formation, if we are mapping like that, that will be called as a fact constellation or galaxy schema. So like that, fact constellation has can have the multiple fact tables, that can have the multiple dimension table, so we can call as a galaxy schema. The sales fact table is same as in the star schema we have seen in the example, the figure. The shipping fact table that is having the dimensions, that is item key, time key, shipper key, from location and to location, right? So the second fact table which we have seen in the fact constellation, rather than star and Snowflake schema, that was not there. So in that is having the dimension, these are. The shipping fact table also contains the two of the measures. So here the term comes as measure, that is nothing but the dollar sold and unit sold. So measure is nothing but that we are calling as an attribute, right? So we will see this term in the brief. So it is also possible to share the dimension table between the fact table. So we have seen in the example, the fact table, both of the fact table is sharing the dimension tables, right? So in the first fact table, sales that will have the 4 of the dimension tables, and in the shipping table, fact table, and that is also using the same item and 2 of the dimension table from the first fact table, so that there is a possibility they can share the dimension tables also. For example, time, item, and location dimension table are shared with the between the sales and shipping fact table, right? So that was from the example. schema definition. So while we are mapping the schemas, so for that we need to the analyst that we have to need as a write everything into the form of query. So there we will use the query language to write the queries, different queries to get the answers, right? So in the multidimensional schema, that is defined using the data mining query language. So in that we will use the DMQL, data mining query language, to write the some of the queries for that, right? So for the schema we are writing everything. To writing the schema, we are having the schema definition, and that we will write into the some of the structure, some of the syntax, and that we will write with the help of the data mining query language. So the two of the primitives, cube definition and dimension definition, can be used for the defining the data warehouse and data marts. So cube will be defined for the data warehousing and dimension defined for the data mart, right? So for example, for the schema, for the cube definition schema will be for the same, that will be in the DMQL language defined, then cube, then it will go to the cube name, then dimension list and measure list. So with the column it will be associated, right? So the syntax will be for the dimension definition, dimension table definition, that will be the defined dimension that up to dimension name, as attribute and dimension list. So the schema will be written like that. That is nothing but the schema definition for the same, that is having the DMQL syntax. So for the data mining query language DML, the language primitives will be there. So like this, we can see here the schema will be written in the real example. So first will be the there will be the cube definition for the fact table. So here will be the fact name, right? That will be the cube definition. Then again that will define the schema. So it will start from the defined cube name, like we have seen in the how we are defining the cube. Again the dimension definition, dimension for the dimension table. So for each of the dimensions, for each of the fact tables, we need to write the query for that. So we will write the dimension while we are that is a function we are calling the dimension definition. So we need to write that. So we'll call the dimension definition dimension table. Again we will define the dimension table syntax, right? Like this for the till that. And for example, if we are having the shared dimension tables, so for that, in that of the cases, in that we have seen in the fact constellation data model. So in that we will use the first time as cube definition, like this is the symbol we will use if we are having the more than one dimension table. So definition, define dimension name first time in cube first time. So like this, this is the syntax for the some of the special cases when we are having the more than one dimension table. So that was all about how the in the real time example the schema definition syntax we are using. So the syntax will be for the star schema definition, that can be in the form of DMQL query language. So that will be like that defined. Then we need to define the that cube schema. Then the different attribute we need to call, right? The after the colon, that will be start the different attributes. So the $sold attribute that is having what are the attribute that is having will store on that. So that is having the sum sales in dollars, average sales, that is average sales I dollars. For the unit sold attribute, that is having the count of all, right? Again we will define the dimension table time as dimension time, the time dimension as time key, what are the attributes are there for that. Again, define the dimension item, right. Again, for the branch, for the location. So this is the syntax to writing for the star schema. This is the syntax to write to the for the Snowflake schema. So here we will check the difference from the star schema. So here till here define, right, dollar, right, unit, right, define dimension, right, time for the time, item for the item, yeah. Here the fact table introduced. For the fact table supplier, the query is needed to write. So that is the major difference. Again, the definition will be for branch and location. So and all the things will stop here. So these are the 5-6 line we need to write for the Snowflake schema as a definition. For the fact constellation schema, the definition is there. In that, that will share the different dimensions table. So there is no need again and again to write. That will be written as a here. The definition of fact tables will be there. Again, the different attributes will be introduced, and then that will define the dimension, time, item, and branch. And again, we'll see next will be the dimension location. That again will be the fact table cube, fact table shipping. Then yes, then we will write for the dimension table time and item, dimension table item. Then for the shipper, we will introduce the all of the like attributes, and for the if here we are sharing the location from to and to. So here we will write the definition for that. So that was the syntax for to write the for the fact constellation schema. There were a term measure. So a functional level, a function evaluated or aggregated on the data corresponding to the given dimensional value pairs. So that is the thing. Why measure is a like method to evaluate on the aggregated data corresponding to the different dimension value of the pairs. So here the dimensions can be that is divided into the 3 types. The first is distributive, second is algebraic, and third is holistic. So the for the distributive measure, if the measure can be calculated into the distributed manner. So for example, if the measure is having the count, sum, minimum, max, so these are the measures that is used for the calculations. So that will be the distributive measure for that. The algebraic measures will be if if it can be computed from the arguments obtained by the some of the distributive aggregate functions. So here will be the combination of functions. There will be aggregation of functions which is used for the distributive measures. So for example, if you are having the average measure, that is a combination of sum divided by count. So that is nothing but the algebraic measure. So the measure it is used for the different calculations in the combination of different functions that is having the distributive functions. Third is the holistic measure. So it is non-algebraic measure. So rest of all the measures will come into this holistic measure. So for example, median, mode, rank. So these are the statistical functions that is used for to measure the different median, mode, and these are the central tendency values. So this was all about the measures term. What is measure and what are the different types of measures and how many types of measures are there. We have covered the examples also for that. So that was all about the different, we have completed the what are the different schema definitions are there, what are the difference into the different star schema, snowflake schema, fact constellation schema. We have written the definition into the DMQL language. We have seen the uh, some of the terms like measures, we have seen the different fact tables, dimensions tables, and related attributes, fact tables, right? What are the shared dimensions tables? So till now we have covered these all into the brief. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.